Okay, good day. In this video, I'm going to give you the first example about applications of Maxima and Minima. And it says, a long strip of tin 30 centimeter wide is to be made into a gutter with rectangular cross-section by turning up equal widths along the edges. Find the depth which yields the greatest carrying capacity. So, ibig sabihin, meron tayong lata dito ng lapat ay 30 centimeters. Yun yung tin, gagawa tayo ng gutter. Pag sinabing gutter, yun yung alulod nilalagay sa bubong para saluhin yung tubig ulan. At ang cross-section ng ating alulod ay rectangular. Okay? Tutupi yung dalawang gilid. And then, ang tinatanong sa atin ay ano dapat ang height or depth ng ating pong rectangular cross-section para ang dadaang tubig ay maximum. Okay? O yun yung greatest carrying capacity. Now, we're going to follow the steps in the 3 steps in solving max-min problems na present ko doon sa first video. Okay, gawa muna tayo ng figure and that is the first step. Okay. Meron tayong tin. Hindi na naman natin concern yung haba nito. Ang concern lang natin ay yung lapad kasi yun ang itutupi natin. Ito yung ating tin. Okay. Then, itutupi sa gilid para makapagawa tayo ng gutter. Ang lapad niya, 30 centimeters. Sabihin natin x ang pagkakatupi. Okay? And then, x to. Ganito ang maging itsura niya pag tinupi yung dalawang gilid. Okay? Kaka meron tayo ng gutter. Yan, ganyan ang itsura ng ating gutter. Okay? So, pag tinupi yan, kung 30 cm to, ito yung magiging depth nyo. Yun yung depth. Yan. Yung depth ninyo. Ito yung x. Yun ang i-determine natin. Yung height o depth ng ating rectangular cross-section para maximum yung tubig na makakadaan. So, sa makatuwid, ang i-maximize natin dito yung area of the cross-section. Okay. So, kunin natin yung cross-section lang of the gutter. Ganito itsura niya. Originally, siya ay 30 centimeters yung lapad. Siyempre, pag tinupi ng x, so magiging po-fold pag ganito, yung gilid, pag ganito, okay, para maging gutter. So, ito yung x, sabihin natin ito yung y. So, therefore, yung depth niya, ito rin, yung pagkakatupi. x. Okay. Yan. Dotted line yon kasi open naman yung ibabaw ng ating gutter. Kasi pag close yun, walang babagsakan yung tubig. Okay? Now, for step 2, ano ba i-maximize natin dito? Ang kailangan natin makuha ay yung x na kung saan maximum ang ating cross-section. Okay? So, step 2, anong i-maximize natin dito? Yung carrying capacity. Maximum or greatest carrying capacity. Sa case ng ating rectangular cross-section, ang i-maximize natin area. Okay? Yung area. Kasi pag maximum ang area mo, mas maraming makakadaang tubig. Yun yung greatest carrying capacity niya. Okay? So, sa case nito, area of the cross-section. Yun ang ating i-maximize. Yan. Okay? Now, ito yung step 2 natin. Alam natin i-maximize natin. kailangan ay makapag-determine tayo ng isang formula or something like function. Isa lang, kung possible, isa lang independent variable. Okay? Now, ang ating pong relationship between the depth of the gutter, okay, ilagay ko muna, let x, ito yung depth of the gutter, y is base ng rectangular cross-section. Cross-section. Lagay ko na lang ganun. And yung area, ito yung area of the rectangular cross-section. Yan. Okay. So, we need relationship, yung area na i-maximize natin at yung kanyang independent variable na depth of the gutter. Okay. So, we have area for rectangular cross-section is height, length times width. So, happens ang ating length, ang width natin is x, which is the depth of the gutter, and y as the base of the rectangular cross-section. Now, kailangan ilagay natin to as much as possible kung kaya in terms of one independent variable. Dito na papasok yung pinag-aralan nating functional notation na kung saan we set up a formula na kung saan it involves variables. Okay? So, paano natin ilalagay ito? A as a function of x. Okay? Paano? So, ang haba nito, 30, yung tin. Tinupi natin both sides by x. So, therefore, ang matitira na lang dito, 30 minus 2x. Okay? So, ito yung magiging 30 minus 2x. So, therefore, ang ating pong area as a function of x will be equal to x times quantity 30 minus 2x. And that is equal to 30x minus 2x squared. Okay. So, tapos na natin yung step 2 kasi meron na tayo na express na natin yung quantity na i-maximize in terms of one independent variable which happens to be x. Okay? And the last step is step 3. We're going to determine the derivative of the function na nagawa natin dito. And we're going to set that to 0. Now, we have the last step in solving max-min problems. And this is finding the derivative of the set of the function. And we're going to set this to 0 to determine the critical value. Okay? So, derivative natin. So, ito ay a prime or we can use dA over dx. Okay? So, kunin natin si derivative ng ating a with respect to x. Okay? A is the dependent variable and x is the independent variable. Which means, yung area will depend on the depth of the gutter. Okay? Kasi kung mataas ang pagkakatupi, ano ba, pwedeng pa ganito, pwedeng pa ganyan. Kasi, maapektuhan yung area. Okay? So, ang kailangan natin is yung ating depth na kung saan magka-come up tayo with the maximum area. So, kung natin derivative, this is 30 minus 4x. Kunin natin yung critical value by equating this to 0. Bakit po? Kasi naroon yung maximum if the slope of the tangent line is equal to 0. Okay? At naroon din yung minimum. Okay? Kung saan yung ating first derivative is equal to 0. So, therefore, equate natin to 0 to solve for the critical value. Transpose negative 4x, we have 4x equals to 30, divide both by 4 to solve for x. Therefore, x equal to 7.5 centimeter. So, ito ang sagot natin. Ano ibig sabihin yan? yung ating area of the cross-section is maximum kapag ang depth, yung pagkakatupi natin, is 7.5 centimeter. So, A is maximum at x equals 7.5 centimeter. Okay? Narin yung maximum area, and that is the greatest carrying capacity. And part 2 of this video is an explanation on how we can say that area is maximum if x equals 7.5 centimeter. Okay, using the first derivative test. Thank you.